Hey class, let's investigate derivative of exponential functions. There are two different cases of exponential functions you will run into. One of them, you will see a base number of e in your function, and the other is a base number of anything except e. These will be positive numbers for your base. E is Euler's number. Let me go ahead and just progress into these. The formulas are at the top of your sheet, so if you need to pause and write these down, you can also access these in Google Drive. But I'm just going to jump right into taking derivatives. Anything with a base e, we'll use the left two formulas. The very top one, if all you have is e to the x, the derivative is exactly the same. If you have a power that has some other function of x, then you'll make a copy of your original function, but you'll also take the derivative of your power. And we'll go through that with these examples. Okay, so we're going to find the first derivative of each exponential function. Our first example, we have y equals e to the 3x. So any of these exponential derivatives, you make an exact copy of the function. So I'm going to recopy e to the 3x. If the power has a derivative other than 1, you chain that to the end. So 3x has a derivative of 3, so we put that on the end. And that was the bottom formula left side. We have a base number e, the power where it would be a u at the top. That would be the du dx. Derivative of 3x is 3. And then just to make it look clean, we moved a 3 to the front, so the derivative is 3e to the 3x. Underneath this example, we have y equals e to the 3x squared plus x minus 5. Since it's exponential, make an exact copy of your original function. The derivative of the exponent is 6x plus 1, and we multiply that on the end. That's the du dx from the formulas above. You don't have to bring this term to the front. I usually just do it and put my e term second. That's just personal preference. Let's look at the top right of your screen. E to the negative 3x to the 5th. We're going to make an exact copy and then take the derivative of the exponent. The derivative of negative 3x to the 5th is negative 15x to the 4th. I'm going to move this to the front, so this is our first derivative. Once you change your base number from e to just some positive number, like say this example has a 5, some of them have 7, 1/2, then what we'll do is we'll go back up here to the formulas, and it'll be the right side. These are for base numbers other than e. This bottom one is the example of if your power has a derivative other than 1. As long as you have a number like 5 to the x, and that's it, then you're going to make a copy, and then you'll take natural log of your base number. If the exponent has a derivative other than 1, then you will make a copy of the original problem times natural log of your base number, and then times the derivative of that exponent. So let's go back down and we'll look at this example in the upper right part of your screen. Y equals 5 to the x. Back up at your formulas, this would be the very top right one. A base number other than e and just a power of x. So you're going to make a copy, that's going to be 5 to the x times natural log of your base number, which is 5. Let's look at the example at the bottom left. We still have a base number of 5, but we've changed our power up. Now that would be the right side bottom formula in your formulas. So we're going to make a copy, that's 5 to the negative 3x times the natural log of the base. That's the same. Now, what makes it a little bit extra is we have a derivative of our power, which is -3. Since that's not 1, we have to multiply by the derivative of the power. Cleaning all this up, which is optional, I have -3 times natural log of 5 times the original function, 5 to the -3x power. Let's focus on the bottom left example. Our original function is 5 to the 3x squared minus x plus 2. Taking the first derivative, we make an exact copy of our function, times the natural log of the base number, times the derivative of the exponent, which is 6x minus 1. Rearranging if you want to, this would be your first derivative. Now let me point out here on these exponential functions, like at the top right of your screen, we have 5 to the x. If this were e to the x, you would just make the copy and your first derivative would be e to the x, which is that top left formula at the top of the page. We actually do natural log of e, but natural log of e is equal to 1. So that's why when we have examples where we use a base number of e, there really is an ln of e in the middle. It's just not, you don't have to write it because natural log of e is 1. So there actually is that part of the derivative where you make a copy, natural log of e, which is 1, and then times the derivative of your power if that's something other than 1. Recall that your product rule allows you to take the derivative of two types of terms that are different from one another. For example, in this one we have 4x cubed times e to the negative x. Well, this part underlined with an a is an algebraic term, and the part underlined with b is exponential. If you have two terms multiplied together, then you can find the first derivative of your function by expanding that. It's the derivative of the first term times the second term left alone, plus the first term left alone times the derivative of the second term. So let's apply the product rule to this function. We're going to find the derivative of 4x cubed times e to the negative x. Okay, so the derivative of the first term is going to be 12x squared. Let me fill that in a little bit better. Times the second term left alone, e to the negative x, plus the first term left alone, 4x cubed, times the derivative of the second term. So we've just looked at taking derivatives of exponential functions, so we're going to make a copy, that's e to the negative x, times the derivative of the exponent, which is -1. So that gives us 12x squared e to the negative x minus 4x cubed times e to the negative x. And let me make that square look a little bit better. When I saved it as a PDF, some of the two got cut off. Let's find the derivative of y equals 80 times e to the negative 0.025x. Note the base number is e. Our first derivative, I'm going to let 80 be our first term. That's a constant. This e term is our second. That's our, if you look at it through the lens of a's and b's, 80 would be your a. This exponential term would be your b. Derivative of 80 is 0 times the second term left alone plus first term left alone times the derivative of the second term. Since that's exponential, we're going to make a copy times the derivative of the exponent, which is -0.025. If you multiply 80 times -0.025, you get a -2. That's where this -2 came from. This part up here, when we took the derivative of 80 and we got 0 because it's a constant, no matter what it's multiplied by, we're going to get 0 for our result. And so that's why I just drew a red arrow with a 0, because that first term is just going to disappear. 80 times our negative 0.025 gives us negative 2, and then we bring our e term down next to it, and that's our derivative. I hope this video has helped out. Please reach out by phone, email. If you're on campus, come by the office, and I'll do my best to help you out.